Here is a very simple and effective strategy to solve related rates applications. I am Anil Kumar. Welcome to my series on calculus. We will discuss related rates applications in this particular video. The question here is, two cars are heading towards an intersection. Car A is traveling west at 60 kilometers per hour and car B is traveling north at 80 kilometers per hour. At what rate are the cars approaching each other? When car A is 300 meters and car B is 400 meters from the intersection. Now, related rate problems can be solved using some strategies which we are going to discuss. In this particular example, Pythagorean theorem relates the variables, and we will see how rate of change is to be given a sign, positive or negative, after making a sketch. So the strategy is to first make the sketch of whatever has been described, visualize first, and then try to attempt the solution. So we are given that there are two cars heading towards an intersection. So let's draw an intersection, right? Car A is traveling west. So from east to west, right? So traveling west, let's consider this. Traveling west at 60 kilometers per hour, and car B is traveling north at 80 kilometers per hour. Another key word here is that the cars are approaching, correct? So that is how they are trying to approach an intersection, right? So now I hope the idea is absolutely clear. So here is your diagram. So there are two cars which are trying to approach. One is traveling in west. So you'll start from east, okay? So what you have here is a car which is traveling in this direction. You see that? Traveling west. So this is car A which is traveling west. And car B is traveling north, right? So let us say this car is traveling north. And that is car B for us. Make sense? Now another important thing is they are approaching. Since they are approaching, distance is decreasing, right? So let's write down. Approaching means what? Distance decreasing. They are approaching with a speed given to us 60 kilometers per hour. So we can write down this speed as change in x. If this is my x and that is y, correct? So we'll write dx dt as equal to minus 60 kilometers per hour. You get the idea? They are approaching, distance x is decreasing. And for b also, the change in y, let's say, is also negative since this distance is also decreasing with time. So that will be minus 80 kilometers per hour. Do you see how we have given positive and negative sign to our derivative, which represents change in position or the velocity or speed, right? Perfect. Now, at any instance of time, let us say at time t, they are at the position shown, right? In that case, what is going to be the separation between the two? Let's connect. Let's call this as z. Correct? So we need to find at what rate are the cars approaching each other when car A is 300 meters and car B is 400 meters. So these are given in kilometers. So we can write these units, meters, convert them to kilometers, correct? So let me rewrite. So we are given car A is 300 meters, so 0.3 kilometers, right? And car B is 0.4 kilometers. So those are the distances. So x value being equal to 0.3 kilometers and y value being 0.4, correct? So at this particular instance, what is z? Z will be square root of 0.3 square plus 0.4 square, correct? You know, it's a right angle triangle which will give you 0.5. So at this instance, we say t, when we are interested in finding the rate of change, that is the status, correct? Is that clear to you? Now, how are the three variables related? So let us say at this instance, because the x and y values are always changing, correct? So let's consider x to be the distance at this just before it and y to be the distance just before it. In that case, we know the separation z square is equal to x square plus y square. Makes sense? So that is how we have related all the three variables. Now, to find the rate of change, we have to differentiate with respect to time. Is that clear to you? Perfect. I hope the concept is clear. Now, since the concept is absolutely clear to you, I would like you to differentiate with respect to time, right? And get the answer. Perfect. So here is my solution. So what we have done here is that we have related all the parameters. After sketching, the separation between the cars is represented by z, right? At the instance when car A is x kilometers away and car B is y kilometers away from the point of intersection. Is that clear to you? So at this particular instance, as you can clearly see, z square is equal to x square plus y square. Now differentiate with respect to time. Is it okay? So we get what? We get 2z dz over dt equals to 2x dx over dt plus 2y dy over dt. Since we have to find the rate of change of separation, which is represented by z here, we can now rewrite the equation as dz over dt is equal to 1 over z, right? 2 and 2 cancel, right? All these 2's cancel, right? And so you can now write the expression for the rate of change of separation as x times dx dt plus y times dy dt. Is that clear to you? So that becomes a general expression. Now you need to substitute the values and get the answer. Is that clear to you? Correct? So substitute the values which you are given as 0.3, 0.4, and we calculated z at this instance at 0.5. We know dx dt also, right? So the values which we have discussed here, these are the values which you have to substitute, correct? So let's do that. So we have dz dt, separation with respect to time at t when x and y values are 0.3 and 0.4. You get the idea, right? Is 1 over 0.5, the value of z, correct? X value is 0.3 at this time times the rate of change, which is negative 60, right? And then we'll have to add the y value, which is 0.4, times the rate of change, which is 80 kilometers per hour. Is that clear to you? And negative 80. Correct? So substitute these values and then get your answer. Perfect? So divide by this means 2, right? So we can just 2 times. So when you multiply 6 times 3, you get 18 negative. And here 8 times 4 is 32 negative. And that gives you 2 times 2, 3, 4, 50, right? Negative. And that is minus 100. We can multiply this now. Okay, so minus 100. And the rate of change is displacement by time, kilometers per hour. Is that clear to you? That is how you can easily solve these questions. So let's understand this strategy once again. So the idea here is, when given a problem, try to sketch the diagram as we've done, or sketch. And then write an equation. And for that we use Pythagorean theorem, right? So relate. And then do the needful operation, right? So operate. So then you can find the solution after simplifying. Is that clear to you? Perfect. Also note why we have taken the rate of change along x and y as negative in this particular case to get the answer. Perfect. And therefore, the answer here is the rate of separation between the two cars when car A is 300 meters and car B is 400 meters away from the intersection is 100 kilometers per hour. So they are approaching towards one another at this particular rate. Perfect. I hope that makes sense. Feel free to write your comments and share your views. If you like and subscribe to my videos, that'd be great. In case you want to learn from me directly, you can always send an email on the address given or visit our website for more details. Thanks for your time and all the best.